Okay, so where we left off last time was talking about Blue Creek cabins, very briefly, right? I mentioned that the case existed. I just want to show it to you. I want to show it to you that it's not very long. This is the whole thing, right? It's like 2 pages in Word. And what it is, I'm going to talk. Uh, there's a guy who had a business of rental cabins. Okay, so a guy had a rental cabin business in, basically the mountains of Georgia in the US. Okay, so he's renting cabins for people who like to hunt, people who like to fish, people who like to generally be away from other people. Okay, and early on, he starts advertising with AdWords because the costs per click are reasonable. And, what else can you say? He can bid on a wide variety of terms with pretty good results. Okay, so but he starts doing it early on. So this is his initial state. He's pretty happy, right? He has this rental business. He advertises through AdWords. So if people search for things like rental cabins, Georgia mountains, his operation comes up often enough that it gets some clicks and he gets some business from that. Okay, and so he's happy. But what happens over time, right? So this arrow signifies the passage of time. And all this is happening, like, let's say around 2001, right? When AdWords is pretty new. In 2005, Google releases free Google Analytics, right? Which is this web analytics platform that basically tells advertisers, how well they're doing with Google, right? If they're running ads, how much they're making off of those ads in terms of clicks, in terms of people buying sales, all that kind of analytics information that would be a hassle for most businesses to do themselves. So businesses can see, whether and where they're making money with Google. Now, what happens, that drives massive new users to AdWords, right? And because they're having all of these extra new AdWords, bids go up, right? So suddenly what happens is term combinations that used to be profitable no longer are. Also, he's finding he now has enough business from repeats and word of mouth that online advertising is not as necessary as it was. All right. So at this point, he's looking, man, I'm spending a lot of money, but what am I getting for it? Right. I don't need to advertise all over the universe to fill these cabins because, maybe he's got like 45 cabins and in a given week, he's probably filling up 25 or 30 of them. Okay. Because he's an established business now. So the outcome of this, where it all ends up is number one, paying more attention to which terms work and which ones don't, and not bidding for ones that don't. Number two, redesigning the website, right? So he has a website for his operation, redesigning the website to basically include content that ranks high for good search terms, right? So he figures out which search terms are doing a good job of bringing paying customers to his site, and he starts redesigning his site to include those terms in headers and page titles, things like that. And so then, not only improving his ads quality scores, but also making his site rank higher in ordinary search, right? Which gives free clicks. Okay, so this is all the stuff he's doing. This is the outcome of it. Now, it is a little bit of an old article, right? The stuff starts and ends, starts about 20 years ago, ends about 10 years ago. But these basic problems, they don't go away, right? If any of you ever have a website, you want to start advertising yourself online in some way, you're going to go through a similar process. You're going to start off with some set of search terms for whatever reason, you're going to find that some of them work well, some of them don't. You have to prune them. You have to look at what your website is doing, how you can do what's called search engine optimization to have your website rank higher in that, okay, in ordinary Google search results. So these are fairly eternal problems at this point, even though, again, it's an older case study, but the problems don't go away. All right. Anyway, if you want to read that, the article's up there on Blackboard. Okay. Now, next thing, AdSense. So remember, AdWords is when Google shows ads along with search results. AdSense is a different model where the place where the ads are shown is somebody, a website not affiliated with Google. So for example, some blogger says, I want to write blog articles. I don't know how to make money. People don't want to pay to subscribe to my blog. So I'm going to run some ads, right? I reserve a portion of my page, some rectangle in the corner, and I say, Google, fill that spot up with ads. And Google says, yeah, okay, we'll do that. That's the AdWords model. Okay. Now, I could talk about AdSense, but the details of that aren't that important, right? The detail that is important is AdSense solved this big problem. The big problem is, how do you earn revenue from free content, right? So what is going on? You're all buzzing back there. What's up? What's up? Nothing? Something? Nobody ever wants to tell what they're talking about. Very secretive. All right, well, fine. Okay. So the basic problem is this. Digital content is not free to produce, but is easily copied, right? So, for example, you see a news article, you're like, wow, that news article looks interesting, I want to read it. You go to the page, you find out it's behind a paywall. The Chicago Tribune wants to charge you $1 for like lifetime access to their library of news. And you're like, fuck that, I'm not paying $1, right? So you go find the article somewhere else, right? You go browse around on Google and you find that, you know, one of your friends on Facebook or some blogger has basically copied the text of the article and put it somewhere. And you're like, thank you. Okay. So this is the problem that content creators face. They make this digital content. People don't want to ever pay for it directly, right? So what do you do? How do you make money? Well, of course, just like broadcast TV, right? The solution is advertising, right? Basically, make your viewers sit through some ads and the advertisers will pay you for that, right? But the problem is that if you don't do a good job of selecting the ad viewers, the ads will be of little value, okay? So for example, suppose you try, what's something you might, suppose you have like, you're selling ghost peppers, right? In case you don't know, very, very hot, spicy peppers. You're selling ghost peppers, and it's a pretty small, you know, set of people that like ghost pepper, right? A little bit is nice, but there aren't that many people who want to eat whole ones. So if you just put up ads for ghost peppers all over the internet, mostly you're going to reach people that aren't interested. They're going to be like, oh, wow, that ad kind of scares me. I don't want to touch that stuff, right? So what's the point? Yeah, this is the problem, right? If you don't know who your ad viewers are, you can't target the ads properly for them, right? The exception, of course, very popular items, products, brands like M&Ms or McDonald's, you know, a lot of people like these things. You'd probably be pretty safe advertising those about anywhere, except those brands have very finite ad budgets. Even though they didn't make a lot of ads, right? McDonald's more than M&Ms these days. Even though they make a lot of ads, there's not enough money in their advertising budgets to slather the internet with ads. So what do? Well, in the late 90s, right, prior to Google reinventing online advertising, you had one size fits all banner ads, right? Basically, a page would have a big ad across the top, and all site visitors, page visitors, would see the same ad. Needless to say, this was not a great model. The vast majority of things you were showing to people were of practically no interest to them. You were selling like car purchases to teenagers, to young teenagers, or you were trying to advertise ghost peppers to, people with sensitive digestive systems, right? Stuff like just didn't work out. So this consequently, advertising like this was nearly worthless. And, again, content creators could not really get paid, right? If at a minimum, the content creators aren't making enough money off of ads to cover the cost of having their website hosted, right? What are they even doing there? So the solution, of course, was Google, right? Google says, we can pick effectively which ads should go on which pages, right? Now, with search terms, this is actually a pretty easy problem, right? It might not sound easy, but as this problem goes, it's easy because, many users use the same exact terms, so you can figure out which ads are working well for those. And many others use similar overlapping sets of search terms, right? So once again, Google would say, oh, somebody's searching for car sales Chicago. Well, is that really close to car sales Chicago suburbs? There's probably some overlap there, right? And you can see the sort of ads that work. And with search terms, that sort of analysis is easy to do. Now, without search terms, though, it's possible but difficult, right? Google has to figure out what the page is about in some sense and translate that into what ads could defensively be shown on that page, right? Which ads go well. Well, there's a lot of different content types out there, but each one of those is a pretty broad umbrella, right? Search terms are pretty narrow and focused. Site tags, not so much. You could have any number of shoes combined with locations, combined with brands, combined with men's, women's, children's, whatever, baby shoes even, right? But you're not going to have that many tags probably for a web page, right? You just have like, well, this page is about shoes, right? It's harder to do. And so since the problem is more difficult, the predictions will be less accurate, right? For, regarding who clicks. And I looked this stuff up this morning because I hadn't looked it up in a while. I always say like numbers between 1% and 3% are pretty good. Google claims that they get for their targeted ads, right? The ones that are used search terms and whatever other information Google has, they say that that's climbed up to like 4 to 6% now, which good for them. But for AdSense, the AdSense model that doesn't involve search terms, it's down to like 0.5%. All right. So again, it's good enough they can make money on it, but it's way less effective than the search term approach, right? The problem is a lot of people are using these other mechanisms besides search, right? Google search isn't quite the thing it used to be as far as unlimited growth. I mean, obviously people still use it, but yeah, a lot of high-paying people have gone away. So if you read all the way to the end of this article, for example, you can see here at the end, where is this? There we go. I thought it was at the end. Okay. For example, in the first half of 2012, Amazon reportedly spent over $50 million on Google Ads, right? That sort of spend is a big reason why Amazon decided to develop its own app. And, now a lot of people have Amazon apps on their phone instead of Amazon advertising through Google. I remember when you couldn't wake up in the morning without hearing a University of Phoenix ad, right? So about 38 million there in ad spend for the first half of the year for a university, right? Which again, that's a 38 million for a university is a lot. So anyway, there were operations spending a lot of money on this, and hopefully, they were getting what they wanted from it, but they're looking for a way out, right? If they're spending that much money, they're like, how can we do better? How can we get the same results somewhere else? Okay. So that's the takeaway, right? So AdSense it did solve the it did solve the problem for content creators, how they could make money off of their original content. But the fact is, it doesn't do it quite as well or nearly as well as ordinary Google ads shown with search results. Okay. All right, so that's all this stuff right here. You know, again, perfection is not essential for profitability. Even with all of Google's AI working, you know, they're getting like 5% click-through rates on ads. You know, that means 95% of the time they're failing. So, all right, but they're still making money off of it for sure. Okay. Let's talk a little bit about clicks. Okay, so there's 3 real click models, right? 3 ones widely used these days. I'll blow it up. Number 1, the advertiser might pay Google whenever the ad gets seen by somebody. That's called pay per impression. The typical abbreviation is PPM for paid per thousand. The M is Roman numeral for 1,000. And the idea is for every 1,000, pairs of eyeballs that see the ad, Google has to pay like, $1 or something. Pay per impression prices are usually pretty low. Okay. The second one, when an ad is clicked, pay per click. That's the most common method. Google shows the ad to somebody. If somebody clicks on it, then the advertiser pays Google. If nobody clicks on it, then nobody pays. Okay. And the last one, when a purchase happens, which is called a pay per conversion. So in web analytics talk, a conversion is when something that you want to have happen on your website happens, right? The technical term is a goal conversion, but the idea is, whatever you want people to do on your website, whether it's a purchase or finding what they're looking for, like if you're irs.gov, you're not selling anything, but you hope people find the files and forms they're looking for, right? Whatever you want people to do on your site, that's a conversion. So in the case where you're a retail site and you say, well, I'm only going to pay Google if somebody clicks on the ad, goes to my site, makes a purchase. Okay. Now, pay-per-click is the most common of the 3. And the reason is it's medium risk, right? Everybody shares the risk, both the advertiser and Google. So let's take a moment. We'll talk about this because, again, this is an important core concept. Screen. Thank you. Okay, so risk in this context, nobody's directly losing money, right? But the question is, someone might show an ad or pay out without getting anything, right? Someone might do their part without anything to show for it. Okay, that's what we mean by risk in this context. So if it's Google, they might show an ad, not get paid. If it's an advertiser, they might pay for advertising, not even get anybody to come to their site. Okay, so pay-per-click, like I said, this is in the middle. There's some risk for both. And if we'll put more risk, advertiser takes on more risk, we'll put it this end, and Google takes on more risk, we'll put it this end. Okay, so which of those 3 models, or I guess the 2 that are left, pay per impression and pay per conversion, which of those does Google take more risk with? Pay per impression, pay per conversion. Which one? Why would Google take on more risk with pay per impression? Just a guess. Okay, well, 50. I got to give it. Yeah, it's per conversion, but hats off to you for guessing, right? So I'm going to go off on a tangent. I went off on a tangent this morning. So there's 2 kinds of psychologies in the world. One of them is the sports psychology. The other is the engineer psychology. Now, for better or worse, I come from a long line of engineers. The engineer philosophy is you approach a problem and you want to find a really good solution for it, right? So if your problem is get a football from one side of the field to the other, your solution is you build some giant slingshot or cannon or some armored train to just drive that football to the end and nothing's going to stop it, right? That's the engineering approach. You have one problem, you go after it, you solve it. The sports approach is more of a, let's try some shit and see what happens, right? The sports approach is finding arbitrarily difficult ways to do things that really make no sense. For example, take soccer, right? Soccer, okay, you got to get the ball from this end to the other end of the field. But it's not just the other end of the field, right? You got to get it through this little goal. And it's not just an open goal. There's a guy standing in front of it trying to block it. And guess what? You can only use your hands, or you can only use your feet. I guess your head and your chest, whatever, if you need to, but basically only your feet, right? Why would you even design something so crazy? Well, that's the sports psychology, is you come up with arbitrarily difficult challenges that then you can go, ooh, we did it, right? When you finally did something crazy unlikely. Now, may happen that many of you in this room have an engineering psychology. The engineering psychology says, well, find the right answer and do it, right? As opposed to the sports psychology might be, raise your hand, maybe you're right, maybe you're wrong, whatever, we'll get on with this thing, right? But once in a while, you're going to be right. Now, the payoff happens. So it might seem that there's not much to justify the existence of the sports psychology, but there is. In the dating world, sports psychology is infinitely superior, right? If you have the engineering psychology, you find somebody you like, you think about them for months, you spend all this time trying to think up the optimal way to approach them, and then, it turns out they never really liked you like that in the first place anyway. Or else maybe you had a moment a couple months ago, and by the time you figure out your solution, it's gone, right? Sports psychology is like, oh, yeah, I like this person. I'll go talk to him, see what happens, right? Maybe 9 times out of 10, you get flamed, right? But the 1 in 10 you don't, good for you. Okay, so that's my tangent. And so anyway, it appears that a bunch of you, I don't know, maybe you're all engineering types, I don't know. Okay, so back to where we were. Pay per conversion is where Google takes on more risk, right? And the reason is Google only gets paid if a sale happens, right? Assuming that that's what the conversion is. Conversely, you have this option, pay per impression, okay? In this case, pay per impression, advertiser has to pay Google regardless of whether any ad viewers are interested, right? Google could show that ad to anybody anywhere. Google's still going to get paid. Google's not super motivated to optimize who sees the ad. Okay, so where are these appropriate? Well, pay per impression can be appropriate for products that will not be directly purchased through the ad, right? So ads for generating buzz around a product. For example, suppose the studios come up with a new Marvel movie. It's going to be out in like 6 months. So they start running some teaser ads around the internet, right? So they say, oh yeah, here's the movie you get to look forward to, right? Ant-Man and Wasp 5 or whatever they're up to now. And, they know 6 months out in advance, nobody's going to go buy tickets, right? But people will see it and maybe get a little excited. I don't know. Or, there's something about the Star Wars movies, right? They'll say, this one's better than the last one. We promise. Come watch it. Okay. Pay per conversion, on the other hand, this is appropriate for advertisers with a very limited advertising budget. So if you're some small scale operation, you basically have enough budget to pay Google for like 10 or 20 clicks a week, you want to make sure you get something for those. And it's probably worth it to make sure, right? If you're small. But if you're big, right? So think about it. Suppose you have like a 3% chance that somebody who clicks on one of your ads actually buys your product. You can, as an advertiser, you can do that math, figure out how much profit you're making off the sale, figure out how much the clicks cost you, and figure out what's an appropriate bid per click. But what happens over here with pay per conversion, Google will charge a risk premium. All right. So if you say, for example, the amount that you would pay to get so many actual purchases is X, right? It costs X to get so many purchases leading to so many, or so many clicks leading to so many expected purchases, right? Realistically, going to cost about 2 or 3x here using pay per conversion, right? Google is going to expect to be greatly compensated for the fact that they're basically guaranteeing you an income stream. All right. So if you are a big operation and you're selling, you're running an ad 1,000,000 times online, you don't need to pay that premium, right? If you're pretty confident that your, click-through rate leading to purchases is going to be like 3%, you're like, okay, we'll show this 1,000,000 times. We'll get 30,000 purchases from it. Great, that's good. We don't need to pay some inflated rate for pay per conversion because we're pretty sure we're going to have people buy through the ad. Okay, so this is why pay-per-click is popular. Pay per impression, like I said, largely suitable for ads that aren't directly selling something or aren't immediately selling something. Pay per conversion is good where the advertiser is really cautious, typically where they have a very small budget. And pay per click, that's pretty much everybody else, everybody who's big and actually selling a product, which is most of your online advertisers. I did have a student several years ago who was telling me about, he had a site where they were selling used cars, right? And they tried for a little while advertising through Google, but they had this problem. The problem was, the cost per click was pretty high to actually get their ad to show high enough for anybody to click on it. But most of the people who clicked on the ad, didn't come in and actually buy anything. And so, they were just losing money from that. And eventually they pulled it. And I said, well, Google now offers pay per conversion. And he was like, yeah, but they didn't back when we ran this. So it is what it is. Okay. So pay per conversion is nice if you're a small operation. Okay. Now, again, numbers for ads, here again, for a well-targeted search ad, maybe 1 to 3%. Like I said, Google claims it's a little higher these days. That's good for them. For most other online ads, way less than 1%, right? So AdSense, about 0.5%. Other online ads, this double less than means way less than 1%. So think around the order of 0.5% is maybe a good number there. So, and a lot of those are going to be accidental clicks anyway. Okay. Let's do another question. I can tell everybody's waiting to do another question. So let's do number 20. Let's see how that goes. Oh, you got here just in time if you want to do the second question. All right. All right, 10 seconds. I'm not going to do the countdown. We're just going to go to 110. All right. Ding, ding, ding. Okay, that's that. Okay. What's the right answer? Interesting. Okay, well, let's go through it. Yeah, apparently this is a tough one too. Correct answer once again is A. So reason is, right, so ads shown with search results, that's AdWords. Pages not closely affiliated with Google, that's AdSense, right? So for both of those, sure, Google's going to pick which ads are going to be shown on which pages, right? Google's going to show one set of ads for a particular page with some search results and another set of ads for a different page from different search results, okay? Primarily uses a pay per impression model. No, if you got that, we just like a minute ago, we talked about how pay per click is by far the most popular model. So if you answered B, I don't know, you either click the wrong button or you're zoning out. I don't know which, maybe both. C, in both, Google selects ads primarily by search term association. Well, let me say it first of all, Google would love to be able to use search terms for both of those, right? For AdWords, they definitely can. Every AdWords display is preceded by an actual Google search. But for AdSense, a lot of times people get to those pages just by clicking on other links outside of Google, or maybe clicking bookmarks, or just knowing the URL of the page they're going to, right? There's no guarantee for any AdSense user, right? Any AdSense site that people are going to get to that by using Google search. So Google can't count on search terms even being part of the process. That's why they have to use site content analysis. Okay, so again, correct answer was A. So that is why. All right. All right, moving on. So talk about good clicks and bad clicks. Now, of course, Google wants everybody involved in the advertising process to be happy, right? It wants the ad viewers to be happy. Ad viewers are happy if they see relevant ads leading them to safe sites, right? That's great. Advertisers are happy if the people who see those ads go to their sites and, eventually buy something. Then advertisers think that's great. And Google, of course, Google is happy if it makes fat stacks of cash from all those clicks, right? That's what Google wants. So everybody wants to be happy, and all of those three things can go well together. If Google is showing the right ads to the right people, those people are going to click more. The advertiser will pay Google, but the people will pay the advertisers, and everybody will be happy. And the people get stuff they like. Okay. But of course, with just a little thought, I imagine you could come up with some vulnerabilities in that model. For example, suppose you're an unemployed blogger, right? And you're not a very good writer. And so nobody comes to your blog, even though you're running AdSense on it. And you say to yourself, man, I would really like to have a pizza this week. So I'm just going to start clicking on ads on my own site over and over. And if Google's not paying attention, they could pay you money for those phony clicks, right? Likewise, what if there's some corporate warfare going on, right? Target and Walmart, they both write scripts that browse around the internet, and every time, a Target bot sees a Walmart ad, it generates a virtual click on it that Walmart has to pay for. And every time the Walmart bot sees a Target ad, it generates a virtual click that Target has to pay for, right? Then both of those companies are going to ditch Google. They're going to say, this sucks. We're, getting all these clicks and nobody's buying anything. What are we paying for? So, and Google doesn't want that because, obviously Google doesn't want people to abandon the system, and Google doesn't want to pay anybody for phony clicks. So Google tries to figure out which clicks are legitimate, which aren't, by things like the volume of traffic, right? For example, imagine if unemployed blogger is sitting in his chair over and over, reloading the page and clicking on the ad, right? Realistically, nobody does that. Google can recognize, gosh, we're never going to find the same IP address clicking on the same ad like 100 times within half an hour. That's not real human behavior, right? Likewise, time between clicks just generally. Think about the course of a typical day for you, how much time you spend online, how many ads you see, and how often you intentionally click on one, right? I imagine at a minimum, several hours between typical clicks, right? And Google's going to recognize that. Google says, oh, wow, this one phony user, they're just clicking on different ads every minute, right? Google's going to recognize something's up with that. Even ordinary behavior on site, right? Google can compare your behavior to a typical user, right? So it may well be that on occasion, a user goes to a web page and within 5 seconds clicks on an ad and does nothing else. That probably happens once in a great while. But if you as a user are doing that consistently, instead of navigating through the site, scrolling up and down a little bit, clicking on something besides an ad, to finally, after being on the site like 5 or 10 minutes, you click on an ad, right? Google's going to say, oh, wow, look at this user. They're just clicking on ads. That's all they do, right? They're going to flag that. Anyway, those kind of clicks that Google decides are illegitimate, they don't earn money, right? Basically, at some point during the month, Google will send a notice to their AdSense affiliate saying, yeah, we think you're going to get this much money during the month, but that's based on our, analysis project. And it's quite typical for AdSense people to get like less than half of those initial projections, right? Google say, after analyzing the data, we determined that, 60% of your click traffic was invalid. And so you get, instead of $100, you get like $40. Now, the way this process works, right, is basically exactly the same as these other models we've talked about, right? So Google comes up with some model of baseline expectations for actual human behavior. And then it looks at the behavior it sees from any particular event, right? And if it's close enough, if it's within that range, right, to that baseline, Google's going to shrug and say, close enough, probably actual human, right? If it's outside that range, Google's going to look at that and say, probably not human. You know, same thing down here. Probably not human. Because why? Because it's outside those normal bounds. Now, this sort of setup is never going to be perfect, right? You can have, just like all these other cases that we've talked about where this sort of model gets used, right? We've talked about similar models for product recommendations, right? You're not always going to get recommendations that are great for you. Things like spam folders, right? Sometimes legit email goes to your spam folder. A lot of times spam folders don't catch all of the spam, right? Things like fake Facebook accounts, right? All these kind of things we've talked about. This is that same kind of model here, right? Google says, yeah, we have an expectation of what stuff is going to look like. We've built that model. If the interaction looks similar, we're going to let it go. Now, the other thing to remember, if you want to get away with this, and I'm not saying you should, but basically survival depends on staying small scale. All right, so grocery store example, right? You guys know that if you go into a grocery store and you very obviously walk out with a few bags of grapes, you're probably going to get store security called on you, right? I mean, for all the talk that there is right now that basically like shoplifting isn't prosecuted, whatever, but still, most of us aren't going into a grocery store and walking out with bags of food and expecting that nobody's going to care, right? Right. So, but if you're walking through the produce section and you see the grapes and the grapes look good and you say, I better test a few of these to see how good they are before I buy them. And you pop a few in your mouth and eat them right there. Nobody's going to call store security on you for that, right? Same kind of problem. So if in this case of Google, right, suppose in addition to being a blogger, you're also a hacker and you have somehow gained control of a worldwide botnet involving tens of millions of machines that if you want to, you can control remotely, right? Well, in that case, you could say, hey, every day I'm going to generate some random subset of bots that are going to go to this website. And once in a while, maybe 2 or 3% of them are eventually going to click on an ad during the course of a few minutes visit, right? Yeah, you could absolutely probably get away with that with Google, right? Because Google's going to say, oh yeah, there's a bunch of random users. Who knows? It seems legit, right? Especially if you add in some extra profile stuff, like you make some of those bot machines regular visitors and others not so regular. You know, there's ways you can tweak it more to make it more human-like, right? But the fact that you have out of tens of millions of bots, you have, a handful of actual ad clicks over the course of the day, that's chasing crumbs, right? And Google's not going to spend a lot of effort trying to figure out who's chasing crumbs at Google. They're going to figure like, yeah, now and then we're going to miss something. Some people are going to get out with a few dollars worth of stuff, whatever. We're still making like 200 billion off of this. So fine, it is what it is. Okay. So again, that's how these operations get through. And again, if you have a botnet with tens of millions of bots under your control, realistically, you're not going to use that to try to, steal a few dollars a day from Google, right? That is not a good return on your criminal investment. So there's a lot more damage and a lot more money you could make doing other things. Okay. Now, we talked about ads as objects, right? Talked about objects generally. So I want to talk about APIs. So all this time that we've been talking in this course, we talk about interfaces between applications, right? APIs are the technical term for that. So what APIs do, like in all the cases we've discussed, APIs enforce information exchange standards between applications, right? Basically, inputs have a standard format and outputs have a standard format, right? So for example, if you're talking about ads, you might have a website. You know, we have some website, not actually the browser, but website application, like web server application, and it interfaces with Google. So you have reserved space for an ad to go here, okay? And there's some interface between you and Google. All right, so I'm just going to draw, this is the interface. And over here, Google Systems, right? Google's ad database. Okay, so when somebody loads this page, one of the things that happens is there'll be a script running on the web server that says, gosh, I have this blank spot on this page. I need to pull an ad from Google's database. So they send a call to Google. It says, you know, ad please. And that request gets forwarded to Google's ad along with the specifications, right? So it'll be some information about, you know, size and possibly, you know, image or video, right? But at a minimum, they need to know what size is this ad going to be. Is it going to be 400 by 400 pixels or 800 by 600, whatever, right? They need to know that. And so the ad request gets sent to Google, and then Google sends back some ad that meets those criteria, right? And that's pretty much what the API does. Ad meeting criteria, whatever they may be. So the interface makes sure that Google's ad system only receives legitimate, well-formatted requests that say things like, give me an ad with such and such dimensions, right? Not something like, send me an invoice for, you know, somebody's parking operation, right? That would be something you wouldn't want to send there. Likewise, when Google sends a response back to the interface expects that it's going to receive an ad from Google, and it can pretty much just forward that in some standard form. So it'll be an ad with a certain size, maybe other things like destination of click, right? Other things like image rotation, anything that needs to happen within the ad that's special, the interface can potentially be structured to include parameters for that. Okay, so that's what this interface, in this case, we're talking about an interface between Google's databases and the web server application that constructs the pages, but APIs, they're these generic interfaces between any two applications that have to exchange data in some kind of standard way. All right, and the nice thing about this model is Google doesn't need to know about the user's hardware or operating system or browser version or screen size. I guess that is hardware, but that's not the hardware I meant, right? Or anything else, right? The interface is just set up so that as long as the web server can properly interpret the data from Google, all is well, right? Google doesn't need to specify that ad uniquely for anything about that web page other than the size of the box that the ad's supposed to go into. And that's the real magic of APIs, is that you can change stuff on this side and Google doesn't have to change its database setup, and Google can change its database setup. And as long as the ads they're sending to the interface are the same, it doesn't matter what Google does on its own side. Okay. All right, so that's pretty much it. We talked about these in a generic object sense earlier. So the typical language for constructing these objects would be JSON, JavaScript object notation, which again, talked about that. It's compact, it's widely used even now. The older version, XML. XML, you can use it, but it's bulky. It requires a lot of wrapping text to enclose the actual data. And so you don't see it very much these days, right? You might, at this point, you might go your entire life without seeing much in the way of XML, but it still exists. So, all right. Okay. So the rest of this is about Google's databases. And Google, as you might guess, has massive, massive databases for doing a whole bunch of stuff. Now, it might be surprising, might not be, that Google's advertising runs on what's called, it's basically a SQL system, a relational database system, although it uses an extended instruction set with extra capabilities called NewSQL. And the base platform is what's called Spanner. And I'm going to draw a little picture. Screen, I don't need to do so. Whoop. Called Spanner because it spans across the entire operation of Google, right? And then different database systems will receive data from Spanner. All right, so this is a point I want to distinguish between operational data and what's called analytics data and data for analysis. So most businesses, they receive data in a lot of different formats in a lot of different databases. For example, Google all the time, it's receiving data in the terms of searches, it's receiving data in terms of web analytics, it's receiving data from, I don't know, going out and combing through the internet and finding web pages, right? And all of that is going to be in a bunch of different formats. That all gets piled into what's called a data lake. So a data lake is a giant cluster of databases that all have data in potentially very different forms. But what you want to do is take data from that data lake and have prepackaged sets of it, pre-formatted subsets that you use for particular purposes, right? So for example, you can take some data out of Spanner and send it to the advertising database, right? And whatever other databases have, you could take some out of Spanner, send it there, send it there. Okay, we'll build on this, but F1 is the advertising database. Okay, so attributes of that. Number one, it is a very big relational database system. Reason why it needs to be relational is at a minimum, there are going to be two different ways that Google might search for ads in it. Number one, it might search for all ads from a particular advertiser. And number two, it might search for all ads involving a particular keyword, right? All ads for shoes or cars or, energy drinks, whatever. Okay. So it needs that possibility to look at that data from different angles, to, find things in different ways. And relational databases are great at that. However, like NoSQL databases, it has to be really big to run on different pieces of hardware at the same time, right? This F1 database is very, very, very big, and there's no way you're putting it all on just one hard drive. Now, operationally, when you're talking about showing ads, Google wants to deliver pages really fast, even pages including ads. That means this whole system has to be optimized for looking up ads very, very quickly, right? Because it doesn't want that time it takes to pull ads from the database to really interfere with how long it takes for Google to display, the search results page. So to do that, the relational database model is basically faster. We talked, as long as Google can solve certain problems with that, the fact that Google knows which ads are in which places and what fields they have, it's very quick to run, a set of queries on that and find matching ads quickly, right? As opposed to a NoSQL model with no inherent field structure, Google has to comb through all the data in every ad to find whether it matches a query. So Google wants to use it in a relational format. The other thing that's worth mentioning, why is Spanner the way it is, right? So Spanner is basically a system that uses SQL, but approaches NoSQL performance levels. We'll talk about that on the next slide. But this is a thing. Spanner provides almost immediate consistency between different copies of data. So if you change one copy of a data, boom, it basically instantly changes every other copy of it, all the backups, even though it's a distributed system, right? It might have different copies of different data centers. So even though it's really big and has data in different places, it still basically follows ACID properties for all practical purposes. And we've talked about how that is a big problem. How if you have a big database and it's split up with different copies in different parts of the world, maintaining ACID properties is a very difficult thing to do, right? We talked about how Facebook basically follows eventual consistency. If there's two copies of a post, one at one data center gets some likes, it might not be immediately updated for another copy of the post at another data center. So here's the slide. I'm going to cover this, and I'm going to show you the magic. So people talk about this as if it's magic, and it's not. So traditional relational database, right? This is all our same Facebook module stuff. So this is review. If you have an ordinary, SQL type database following ACID properties, it's great as long as the database isn't too big. As long as you can operate it entirely in RAM on one machine, it's going to be pretty fast. And as long as the schema don't change too much, right? By schema, we mean how the database is set up. So what tables are there and what are the fields in the tables and what are the formats of those fields. As long as that doesn't change, then it's relational database systems are going to be pretty fast. On the other hand, you have NoSQL systems, right? NoSQL systems, depending on what you're doing, they could be very fast because they're not bound by ACID properties, right? They don't follow those. And so instead of making everything happen in a very orderly but potentially slow sequence, they can provide, some breaks to data integrity. In cases where data integrity isn't super important, NoSQL systems can be a lot faster. They can break isolation. Also, if you have something like a key value store where every record is like a unique table format in that database, NoSQL systems are going to be super flexible. It's already built in that you can change the structure without too much hassle, right? What you give up is generally the ability to do queries across tables, but still they're going to be flexible, right? You can change the format very easily. But again, some systems, relational databases, strict isolation, all that, very important. Things like transaction processing, you want to follow ACID properties. Things like document lookups, where you're pretty sure that people aren't going to be changing the documents very often, and where the documents can have wildly varying sizes, probably some kind of NoSQL system is going to be the better option. Okay? But Spanner falls in the middle. Spanner says, you know what? We can do a lot of stuff really fast, and we can make it also really flexible. Well, how does that even happen? Well, I'm going to tell you. We have this. We have the green axis. Okay? So the y-axis is consistency. If you want different copies of the data to be consistent, you're following ACID properties, right? Speed and flexibility, generally you're having NoSQL systems. Again, if we're talking about very large databases. But this third axis, the fact that I drew it in green is significant. What do you think this third axis might be? If you said money, you are right, okay? The fact that Google has a lot of assets, they're able to buy massive, massive banks of RAM and use that. So all of these things, if you have basically infinite RAM, then your traditional relational databases can handle a much wider range of problems, right? And if you have super fast network speeds all around the world to your data centers, you can handle those updates in a distributed system basically instantaneously. Okay, so the fact that Google puts a lot of money into having, the same hardware available to anybody, but just faster hardware overall. There's nothing like special about Google's RAM. It's just they use RAM where other operations might use disk. That enables them to do stuff a lot faster. Whoop. And that's what Spanner's all about. All right, that's good. All right. This is why you're not supposed to bring beverages to lectures. All right. Okay. Now, a couple systems that Google has. Number one, BigQuery. So BigQuery is designed to allow queries on very, very, very large database tables. And when I say very large, I mean tables so large that processing the queries in RAM on a single machine is not really feasible, right? So there are certain operations, certain kinds of what are called joins. Joins are anytime you combine two tables together to look at matches across them, right? It's the basic relational database operation. For example, you have a table of customers and a table of zip codes. You do a join on them to find, a list of customers in whatever zip codes. And in some cases, those join operations could effectively be multiplying the two tables together. So your standard relational database software, what it does is for every record in one table, it combines it with every other record in the second table, right? And for the second record, it does the same, combines it with every other. So basically, you're multiplying the two tables together. So if one table has 1 million rows and another one has 1 million rows, you multiply them together, you get 1 trillion rows. And that's not going to be feasible on, normal systems. Okay. So we're going to skip over the details, but just be aware, very large tables like this require special handling. And one of the cases you might see that in real life is with Google's premium analytics. So ordinary web analytics through Google is free. But if you're a big operation that's getting like billions, literally billions of website visits per month, you can pay Google like 150 grand a year and get access to their expensive advanced premium system, right? Which one of the things that it provides you is access to the BigQuery system. And it stands to reason that if you're trying to do some analytics on your web traffic and you're getting billions of hits per month, right? You're going to have those massive tables, and doing any kind of analysis on those, you're either going to have to build a dedicated special system yourself or use some of Google's advanced technology, right? So that's why the BigQuery system is there. If you're really interested in that stuff, of course, you can always talk about it later, but, I know people, yeah, not so much. Okay, so difference between BigQuery and Spanner, right? So they sound similar. BigQuery can process a lot of data very fast, but so can Spanner. Well, the difference is Spanner is good for a lot of frequent but very simple database operations, right? Things like transaction processing. The individual data operations themselves are pretty small, and it can do a lot of them. BigQuery, on the other hand, is designed to handle really massive database operations that don't come up very often, right? So if you're doing day-to-day transactions, you're selling stuff through Google, you've done website hosting through them, and you're getting like hundreds or, probably not thousands because that'd be Amazon, but if you're getting like hundreds of transactions per minute, sure, do that through Spanner, right? If you have a giant batch of analytics data and at the end of the month, you want to go look through and comb through that and see what you can learn about what might be some good options for site redesign, or figuring out which ads it's time to retire, or which search terms you want to stop bidding on, something like BigQuery is going to be a better option for that. Okay. Now, I'll skip ahead through this. So we talked about the concept of a data lake, right? Data lake is the idea that a business has a lot of data in a lot of different forms and formats, and you want to distill some data from that in regular formats, right? More structured data. Well, the data warehouse is basically the entire store of structured data belonging to a business organization. So whatever you've pulled from your data lake for some particular purpose, that's your data warehouse. And you use that for analytics, right? It's not your operational stuff where you're managing transactions or tracking, video views, whatever. It's at the end of the day, you have all of this accumulated data that your managers want to dig through and figure out what they can do to change your system, whatever. Okay. Data Mart is a subset of that. Okay. And there was a big trend in the 90s and the aughts was creating common systems to bring all of these different systems together. So all businesses were starting to have data lakes by then. And the question is, well, how do you pull all of that data out and get it into one standard format, especially when some of that data is either managed directly by humans or when it's in different formats because it's from different business units, possibly in different countries or under different management, right? It's the same kind of data, but different formats. So you had this idea of what's called the ERP system. And so I'll draw a picture. All right. So suppose you're selling something, right? You're a bicycle seller of bicycles. And there's a retailer wants to know if it's feasible to buy 1,000 bicycles for delivery by December 1st. Okay. Now, around 1990, if you wanted to make that request, around 1990, if you wanted to make that request, you would talk to Susie at the front desk, right? You would say, hey, Susie, this is Kmart. Can we get 1,000 bikes by December 1st? And Susie would say, well, gosh, I don't know. I gotta talk to Bob in accounting and see what your status is if you've been paying your bills. And I'll talk to Joe in finance and see what rates I can offer. And I'll go talk to Aaron down on the factory floor and see how many bikes we have in stock. And I'll talk to our vendors and see if they can blah 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 blah. So there'd have to be a bunch of human interaction to do that. And in 1990, that was fine, right? But what happens is that these companies, they started having websites. Right. And with websites, what happened is people wanted the answers right away. You wanted to have somebody be able to click in, order 1,000 bikes, and instantly get whether that order was possible and what the terms would be. Right. So ERP systems are what enabled that. Basically, number one, they took all of that data that might have existed in different formats in different places and brought it into one place so you could answer that with a single query, right? It wouldn't be you'd have a bunch of separate queries issued by humans to different parts of the business. Instead, you'd run one query and then the database system would handle the rest of it. Number two, it broke down the human part entirely, right? So there were no longer those delays. Instead of waiting 3 to 5 business days for Susie to get back to you in 1990, you just type that in on the website and you'd get the answer right away. All right, so again, right now, what it is, pretty much all large businesses have an ERP system. It's just, a normal thing. And a lot of medium and even smaller businesses do now. So if you were taking a more conventional course, they'd probably spend like a week talking about what ERP systems are and why we have them and all that. But there you go. You get the 3 minutes condensed version. Okay. Last couple slides, then we'll do a question. So supply chain management, as you probably might guess, is all of the work involved in making sure that things are getting to where they need to be in the right quantity at the right times, and you're tracking where they are in transit, you're tracking performance of deliveries, and managing any transactions around who has to pay for what. Okay, so if you have an ERP system with high database consistency, you can get fast and correct supply chain systems. For example, in that image we did here, right, in the old version, it might be that your check is crossed in the mail with the database, right? So you sent your payment like 3 business days before, but they still haven't updated your account status in their system. So when you call up Susie and ask her, hey, can we get some bikes? Susie calls you back and says, oh, sorry, we can't sell you anything right now because it looks like you owe us 10 grand still. And you're like, well, we paid it, right? With an ERP system, all that stuff gets resolved fairly instantaneously. You pay online, the money gets done, it's in the system. Whenever Susie does that database check, boom, it shows you've been paid. Okay, so we'll skip virtual machines, that's fine. Typical problem that might happen is if you have a large system like supply chain that you want to migrate to the cloud, right? So you'll start off, all your supply chain processes will be run internally, right? Using the business's own hardware, own software. Your ultimate goal, having that same system in the cloud. And the big concern is your supply chain management system can't go offline ever, because once it goes offline, then you don't know, where things are anymore. And that's a big problem. So big picture process, what happens? Every component from your internal system, make a copy of it in the cloud. Then you copy all your old data to the cloud. As new data comes in, you start feeding that into the cloud system as well. Over time, you're going to test all the components, test them all working together as a system. And when you're happy with how it works, eventually, you're going to run the 2 systems in parallel for a while. But when you're happy with how the cloud system works, eventually you shut down the internal one and just rely on the cloud one. Now, as far as how this might work out, once you have this stuff powered up in the cloud, so I see here powered by Google, these kind of applications, supply chain tends to generate lots and lots of data, right? 30, 40 years ago, you might have had a very small amount of data per shipment, right? It might have just been where the delivery started, maybe the time at the midpoint, maybe the time at arrival, who was driving the truck, some simple stuff like that. Eventually, though, people wanted richer data. So things like checks at shorter intervals, right? Like every minute of the trip, and things like weather conditions or traffic conditions at every point of the trip. So you could, see, is it a problem with the route or a problem with the driver or something else? So, having richer data, it's nice. It lets you figure out better what the problems are, but it also entails a lot more data. If you're taking data, 500 times during a truck route, it's going to be a lot more data than if you just take one measurement. So what you would find is you get massive amounts of data. So the individual updates, every time you're taking a measurement, saying, oh, the truck is here at, time X, and you upload that, that's going to be a little thing that gets handled by Spanner. And every one of those little updates, whether it's something being handed off, something delivered, or another update, all of those small operations, you probably handle those through Spanner. But if at the end of the quarter you say, hey, let's do a thorough analysis of our supply chain performance and figure out, if we have any bad drivers or if there's any bad routes or, bad weather we should be aware of. Maybe we need to buy a different class of trucks because weather is what it is here, right? That's the sort of large scale processing you'd probably run through BigQuery instead of Spanner. Okay, so that's all of that. Let's do a quick question. Very quick. Number 24, advertising API. boom. And I know we're right at the end, so as soon as you're done, if you want to bail, I will not be offended, but that's the question. If you want to stick around and find out the answer, that's fine too. What is up?
So with the Zoom from last week, will those get put in like to the iClicker, or I won't be able to see that all the way to the end of the semester?
Yeah, I mean, if you were there, you were there, but yeah, they're quite, I'll have to tabulate that at the end.
Okay, cool. Because I was like emailing like on the second Zoom on Thursday, like you kind of remember that, like the questions weren't popping up.
Yeah, the first day we were having some problems, so if you emailed me about that, if we discussed
Okay,
them,
cool.
that's fine. Yeah.
All right, thanks. I'm
Yep.
just trying to kind of gauge like what the changes that I'm gonna have, like for the attendance.
I mean, if you've been here mostly, you don't really have anything to worry
So
about.
it won't be like a full letter grade until like you kind of get far down.
You have to miss a lot to lose a grade, yeah.
Okay, cool. All right,
Yeah.
all right, thanks.
Hey, what's happening? I didn't know you're still around. You
Yeah,
stood up front.
no, the week before last week, where we had online class,
Yeah.
my dog was having seizures, so I had to stay home.
Man,
But I attended lectures during Zoom, but I wasn't able to log into iClicker, so I was wondering.
oh, I didn't use iClicker. I just asked the question straight through Zoom.
I was responding on Zoom too, but I think I see that I'm losing points on iClicker because I wasn't able to log into iClicker. I'm not.
Oh, I mean, there shouldn't have been, you send me an email about it. I can look
Okay.
into it.
All right.
Yeah, I don't know off the top of my head. Yeah, you can do your thing. Oh, yeah. Go.
For the art questions,
Yep.
Are we graded just based on answering them or graded based on getting them right?
It's nice if you get them right, but I grade just on answering them. Yep.
Hey, those like red is not X.
Oh, no. Yeah, that's because I actually marked the right answer. Usually I don't. Yeah, don't worry about it. If you were here, that's what I checked. You're here. Yep. What's happening?
So I didn't notice this today. So
Uh-huh.
it says I participated in a poll, but I still had 0 out of 1 points.
Those are older ones.
This was October 24th, October 22nd.
I haven't updated those yet.
And okay.
I'm a few weeks behind.
Okay, because when I was looking at it, I missed one question out of
Yeah,
3.
so the default setting in iClicker is that it tracks attendance and not, it tracks attendance and not